Hello guys, welcome back po sa aking YouTube channel, PTMI. Sa video ko ngayon guys, i-share ko sa inyo kung paano ang pag-compute ng multi-family dwelling unit load calculation. Example natin guys, meron tayong 20 dwelling units. Each dwelling units merong 100 meter square floor area na meron siyang typical household appliances. Meron siyang 1 kilowatt electric range, 1.5 horsepower room air conditioning unit. Circuit number 1, general lighting and convenience receptacle based sa table 2.20.2.3. Sasabi dito guys na ang dwelling unit ay merong 24 volt ampere per meter square. So ang pag-compute yan guys is kung meron kang 100 meter square per area, i-multiply mo sa 24 volt ampere equals to 2,400 volt ampere. Gamit tayo ng dalawang 20 amperes over current protective device, isang spare. Bakit? Kasi may sinasabi dito sa article na one branch circuit of 20 amperes would be theoretically adequate. However, for flexibility and to allow for future need, provide two 20 ampere branch circuit for lighting and convenience outlet. So gagamit tayo ng dalawang 20 ampere over current protective device, 3.5 mm squared conductor based dito sa table 3.10.2.6b.16. Nasa 60 degrees Celsius ang 20 ampere na wire na TW ay mayroong 3.5 mm squared at 2.0 diameter. So ang gagamitin nating conductor is 3.5 mm squared conductor. Para naman is circuit number 2, small appliances. Basahin mo natin itong article 2.20.3.13a. Sabi dito na, a small appliances in its dwelling unit, the load shall be calculated at 1,500 volt ampere. So, sa pag-compute is 1,500 volt ampere. Didivide natin siya sa 230 volts is equal to 6.5 amperes. Bakit hindi natin pwedeng gamitin ng 15 amperes? Kasi may sinasabi dito sa article na 2.10.1.11 C1. Sinasabi niya dito na small appliances branch circuit, in addition to the number of branch circuits required by other parts of this section, 20 amperes small branch circuit shall be provided. So, gamitin natin 20 amperes over current protective device, 3.5 mm squared conductor based at table 3.10.2.6b.16. Circuit number 3, laundry circuit. Basahin mo natin yung 2.20.3.13b. Sasabi dito na laundry circuit, a load of not less than 1,500 volt ampere. So, 1,500 volt ampere divide to 230 volts is 6.5 amperes. Gamit tayo ng isang 20 amperes over current protective device based dito sa article 2.10.1.11c2. Sasabi a laundry branch circuit, in addition to the number of branch circuits required by other parts of this section, at least one additional 20 amperes branch circuit. So, gagamitin natin overcurrent protective device is 20 amperes overcurrent protective device, 3.5 mm squared conductor based sa table 3.10.2.6b.16. Ngayon guys, i-add na natin sa general lighting, i-add na natin yung sa small appliances, i-add natin yung sa laundry circuit is equals to 5,400 volt ampere. So, i-apply natin application of demand factor based sa 2.20.3.3. Sabi dito na dwelling unit at a first 3,000 at 100% demand factor at ang remainder niya is 35%. So, ang pag-complete nito guys is first 3,000 volt ampere at 100% demand factor is 3,000 volt ampere. So, yung 3,000 volt ampere na yun, i-minus natin sa complete natin kanina na 5,400 volt ampere is equals to 2,400 volt ampere. Ngayon, ang remainder niya ay i-multiply sa 35%. So, ang 2,400 volt ampere multiply to 0.35 equals to 840 volt ampere. Ngayon, ipag-add natin yung remainder sa first 3,000 volt ampere is equals to 3,840 volt ampere. Ngayon dito naman guys, basahin naman natin ito para sa electric range. Kasi sabi dito sa 2.20.3.16 demand factor na electric range na kapag isa electric range, meron kang 80% demand factor based sa column B kasi 8 kilowatt yung ating rating. So, electric range at the 80% demand factor based sa table 2.20.3.16, 8,000 volt ampere times 80 or 0.8 is equals to 6,400 volt ampere. Gamit tayo ng 40 amperes overcurrent protected device, 8 mm squared conductor. Isasabi dito sa baba ng table number 4 na branch circuit load, it shall be permissible to calculate the branch circuit load for 1 range for electric range in according with the table 2.20.3.16. The branch circuit or yung circuit breaker natin ay pinapayagan na gamitin yung or shall be the nameplate rating of the appliances. So, pag compute natin, gamitin natin yung pinaka 100% niya o yung nasa nameplate niya. Dito naman tayo guys sa 1.5 horsepower room air conditioning unit na mayroong 10 amperes full load current. Saan ko nakuha yan? Pwede nyo makuha sa nameplate yan on full load current. May kita sa table 4.30.14.2 na ang 1.5 horsepower at 230 volts ay mayroong 10 amperes. So, 10 amperes times 230 volts is 2,300 volt ampere at 100% demand factor. Gagamit tayo ng overcurrent protected device 20 amperes circuit breaker. Ayon dito sa 4.32.4 na several motor or motors and other loads shall have the ampacity of not less than 100% of the full load current rating of the highest rated motor plus the sum of the full load current ratings of all the other motors in the group. At sabi naman dito sa 2.10.2.2a na a continuous and uncontinuous load where a branch circuit supply continuous load or any combination of continuous and non-continuous load, the rating of the overcurrent device shall not be less than the non-continuous load plus 125% of the continuous load. Sa pag-compute nyo guys, una muna guys, i-add muna natin yung total computed natin kanina with demand factor para sa general lighting. Sa electric range na 6,400 volt ampere at sa air conditioning. I-add natin, isama natin itong air conditioning is 12,540 volt ampere. So para makuha natin yung service entrance conductor, sabi sa article na binasa natin kanina is 125% ng pinakamalaking motor or continuous load. So ang continuous load natin is yung air conditioning. So kaya natin mamultiply siya 25% kasi 125 ang hinahanap niya. Pero including na dito ang air conditioning unit. So 12,540 volt ampere plus 25% of 2,300 volt ampere ng air conditioning unit. Divide natin sa 230 volts is 57 amperes. So gagamit tayo ng 14 mm squared conductor based sa table 3.10.2.6b.16. Gagamit tayo ng overcurrent protective device na 60 amperes. Bakit 60? Kasi next to the highest. So 50, 57, so gagamit natin 60 amperes overcurrent protective device. Gamit tayo ng dahil 60 amperes 5.5 mm squared conductor para sa equipment grounding conductor for grounding raceway and equipment. Dahil 330 or smaller, gamit tayo ng 8 mm squared conductor para naman sa grounding electrode conductor for alternating current system. So may sasabi dito guys na sa multi-family dwelling, feeder or service load shall be permissible to calculate the load of the feeder or service to supply 3 or more dwelling units guys. Sabi niya na kapag 3 or more dwelling unit, pwede mong i-apply ang demand factor for multi-family dwelling unit. So ito yung kanyang table 2.20.4.5 official calculation demand factor for 3 or more multi-family dwelling unit. Dahil meron tayong 20 family dwelling unit, i-apply natin yun. So total load of 20 dwelling units according to the table 2.20.4.5a computation load natin sa general lighting, 2,400 volt ampere. Multiply natin sa 20 dahil 20 units equals to 48,000 volt ampere. Para naman sa appliances, small appliances is 30,000 volt ampere. That's why multiply natin sa 20 dwelling units. Sa laundry circuit, 30,000 volt ampere. Para sa electric range at 100% demand factor, 20 dwelling unit is 160,000 volt ampere. Air conditioning unit 2,300 at sa 20 dwelling unit is 46,000 volt ampere. So total of 314,000 volt ampere ang total computed load natin. Ngayon i-apply natin ng demand factor dahil 20 dwelling units tayo, gagamitin natin is 38% demand factor. So kung 314,000 volt ampere, multiply natin sa 0.38 at demand factor is 119,320 volt ampere. So para makuha natin ang main service entrance conductor, 119,320 volt ampere divided by 230 volts is 518 amperes. So gagamitin natin overcurrent protective device is 600 overcurrent protective device based dito sa article 2.40.1.6 na 500 na tayo sa next to the highest tayo. So 600 overcurrent protective device. Ngayon ang 600 i-divide natin sa 2. Pwede natin gamitin ng i-divide natin yung conductor niya sa dalawang set. 600 divide 2 is equals to 300 amperes. Puntahan natin yung table na merong 300 amperes. Dito tayo sa 75 degrees Celsius dahil above 100 amperes yung ating computation. THW, hanapin natin na 300. Ang available lang is 305 yung gagamitin natin at 175 mm² conductor. So ang gagamitin natin conductor is 2 set of 175 mm² 2 wire conductors at 75 degrees according sa table 3.10.2.6b.16. So yan guys, sana ay meron ako na-share sa inyo at kung nagustuhan nyo ang video ko, huwag kalimutang i-like, subscribe at click ang notification bell para laging updated sa mga susunod kong video. Thank you.